Hello everyone, welcome to the second lesson for Python for Beginners course. For this lesson, we are covering data types and structures. We will look at data types and structures in Python, type conversion and typecasting. We also look at type checking and get instance. A data type defines the kind of value that a variable can hold, and this helps us to determine the type of operation that can be performed on that value. Now we have several built-in data types in Python. We have the numeric type, which consists of int, float, complex. We have the sequence type, which has the list, tuple, and range. We have the text type, which is having the string. We have mapping type, which is having dict or dictionary. We have the set type, which is having sets and frozen sets. We also have the boolean type, which is bool, and then binary type, which is byte, byte array, and memory view. For the text type, we have string, and the shortened version or the class version is str. A string is an immutable sequence of characters. So how do we create strings? We create string by enclosing text in either single quotes or double quotes. Immutability here means once you form the string and the string has been stored onto the memory, it cannot be modified. You get to understand immutability and mutability later. Let's look at some of the string operations. We have concatenation, where we can combine two or more strings with a plus operator. We can also repeat string by any amount using the multiplication operator. We also have membership, where we use the operators in and not in to check if a string contains a substring. We also have the length, where we can use the len function to check the number of characters in a string. Let's look at an example of each to understand better. For this example, we've created a variable called message and we've assigned it to this is Python. Now we are going to display the message on line 3. For the second part, we are looking at string operations. So we have concatenation, where on line 8, we've created a variable called first_name and we've assigned it to Kofi. On line 9, we've created last variable and we've assigned it to Boatin. So on line 10, we are going to concatenate Kofi and Boatin. So we have print into brackets first name, and then we introduce the plus. We are going to add white space as a string because concatenation doesn't introduce any space. So we have first name plus, and then we have a space as a string plus last name. For the next part, we are looking at repetition. We've created a variable called game and we've assigned it to eFootball. On line 14, we have print game times 3. So we are going to repeat the string 3 times. For the next part, we have membership. So we've created a variable called message and we've assigned it to this is Python. On line 18, we have print into brackets this as a string in message. So here, we simply want to check whether the string this is inside the message variable. For the last part, we are going to check the number of characters in the message variable, including white space. Let's run this and see the results. For the results, we have this is Python. This is coming from line 3, where we are displaying this is Python. For the next part, we have Kofi button. So we've successfully concatenated the two variables with a space in between. For the next part, we have eFootball, which has been duplicated, and this is coming from line 14, where we have print game times 3. For the next part, we have true. So this is coming from line 18. So we have to check whether this is inside the message variable. And for the message variable, we are storing this is Python. So it returns true because this is inside the string, which is saying this is Python. For the last part, we have 14. This is where we are checking the number of characters in the message variable. So we have this is Python, but remember we are having white space in between. We are going to count all of them. So in total, we have 14 characters. Let's look at some of the common string methods. The first one, we have case conversion. We have upper, lower, capitalize, and title. This helps us to modify our string text. For the next part, we have cleaning, and under cleaning, we have the strip method. So this helps in removing leading and trailing white spaces. For the next part, we have search and replace. We have the find, which returns an index of a substring, and then we have replace, which swaps text. In this example, we have message 1, which is assigned to this is Python. For line 3, 4, 5, 6, we are going to modify the string this is Python using upper method, the lower method, the capitalize method, and the title method. The upper method is going to convert all the characters into uppercase. The lower method is also going to convert all the characters into lowercase, the capitalized method is going to make only the first character for the string uppercase. For the title method, the first character for every word is going to be uppercase. For the next part, we are looking at the strip method. So we've created a variable message2 and we've assigned it to hello world. But you can see we have a leading white space and then we have trailing white space. So those are the spaces that we've introduced before and after hello world. On line 11, we have print message2 dot strip. So we are going to display the results with line 12. For the next part, we have search and replace. So we've created our variable message3 and we've assigned it to this is Python. So for line 17, we want to find Python as a substring in the message variable using the find method. For line 18, we are going to find Python and then replace with JavaScript. So we have message3 dot replaced. So the first entry is the substring you want to look for, which is Python. And then the second entry inside the parenthesis is the substring that you want to replace. So we have JavaScript. Let's run this code and see the results. For the results, the first part is having this is Python all in uppercase. The second part we have this is Python all in lowercase. For the third part, we have this is Python, but here only the first character for the string is uppercase. For the last part, we have this is Python, but only the first character for each word is uppercase. For the next part, we have hello world. So this is coming from line 11, where we've stripped all the white spaces before and after hello world. So you can see there is no white space in front of the hello world. For line 12, we did not apply any strip method to the message2 variable. So we have hello world, but it's having leading and trailing white space. For the next part, we have 8. So this is coming from line 17. That is the purpose for the find method. So the find method is going to return the index of where the Python starts from. So when you check this is Python, you can count the index right from T until you get to P. So you have 8. So that is why we are having 8 as the result. For the last part, we have replaced. So we searched for the Python substring and then we replaced with JavaScript. Now in Python, we can create dynamic text by inserting variable or expression into string. So this is what we call f string. So let's look at the syntax. For this example, we've created name and age. So for the name, we have Alice, and for the age, we have 25. We can format a string by using the f in front of the string at a particular place where we want to insert the variable. We have to introduce the curly brackets and then the variable name. So here we have print into brackets f, and then we have our string enclosed in a double quote. So we have hello, and then the name variable is enclosed in a curly bracket. We also have you are age years old. So the age is also enclosed in a curly bracket. So when we print the results, it's going to look for the item which is stored in the name variable and then use that value. This also applies to the age variable. So it's going to search for the item which is stored in the age variable and then use that value. Let's run this example in our IDE and see the results. For the results, you can see hello Alice, you are 20 years old. So with this, we have been able to format our string by using the variable names. The numeric type represents numeric value which we use for mathematical operations in Python. So we have two types. We have the integer and we have the floats. For integer, they are simply whole numbers without decimal points. So we have age, which is assigned to 18. So the 18 here is a whole number. We also have y assigned to 100, where 100 is also a whole number. For floats, they are simply numbers with decimal points. So here we have pi, which is assigned to 3.1415. And also we have x, which is assigned to 5.5. We can perform these operations on our numeric data type. So we have a assigned to 10 and then b assigned to 3. So we can perform the addition, subtraction, multiplication, division, exponentiation, floor division, and the modulus, which we looked at in our previous lesson. The Boolean data types represents one of two possible values, that is true or false. We normally use Booleans in logical condition and also to control the flow of programs. So you can see we've created two variables where we've assigned x to true and y to false. So this makes the variable contain Boolean data types. Also, we have print into brackets 3 greater than 5. So this returns false, which is of course a Boolean data type. We also have Boolean operations, which we covered in the last lesson. We have equal to, the not equal to, we have greater and less than. We also have greater than or equal to. The Boolean data type is also used for logical operators. So we have the AND, which returns true if both conditions are true. We have the OR, which returns true if at least one of the conditions that you are comparing is true. And we have the NOT, which reverses the result. So if you want more details into these operators, check out the previous lesson. A list is simply an ordered, mutable collection of items. With lists, we can store multiple values with just a single variable. You can create a list either by using the square brackets or the list constructor. We can store numbers, strings, booleans, and other lists. With this example here, we have mine underscore mixed underscore list. So inside the list, we have different collection of items. We have 10, which is an integer. We have Python, which is a string. We have true, which is a boolean, and we have 3.5, which is a float. A list is ordered because their entries or their element stays at their same position as when they were created. For a list, you can allow duplicated entries or elements. And for the last part, a list can be changed after creation. So you can modify or update a list. So this is what we call mutability. Therefore, a list is mutable. Let's move on to assessing list elements. The first important information here is Python uses indexing. So here, Python indexing starts at 0. Let's look at this example. We've created a variable fruit and we've assigned it to the list containing apple, banana, and orange. So if you check here, the index or the position of apple is 0. That is how Python performs indexing. And banana is having an index of 1 and orange is having index of 2. So take note that for list, the first item is having an index of 0. Python also supports negative indexing. Now for negative indexing, the last element is having an index of -1. And then we start indexing from the end to the start from -1. Slicing simply allows us to extract a portion of a list. This can also apply to strings and tuple, which will come to it. So with the syntax, we have the list, that is the variable name. We have the start, the stop, and the step. So the start is the index number where we want to start slicing from. The step allows us to skip elements depending on the number. We have different slicing examples. We can extract a range, we can slice from the start, we can slice to the end. We can also extract every nth element, we can reverse a sequence, and we can also extract the last n items. So let's look at example for each of these to understand better. In this example, we've created a variable called numbers and we've assigned it to the list containing 10, 20, 30, 40, 50. With the first part, we are extracting a range. So we have print numbers, then square brackets 1, which is the start, and 4, which is the stop. So take note that for slicing, it begins at the start value and ends at the element before the stop number. So let me explain here. Looking at the list, we have 10, 20, 30, 40, 50. So here we have 5 elements. And with the first example, we want to extract the range where we have the start to be 1 and the stop to be 4. So here we are going to pick the elements having the indexes 1, 2, and 3. From the list, the element having index 1 is 20, the element having index 2 is 30, and the element having index 3 is 40. Let's move on to the second part. With the second part, we are slicing from the start. So we have print numbers. Inside the square bracket, we have an empty start, and then we have the stop value to be 3. So it means we are going to start slicing from the very beginning, which is the 0 index. So we are going to pick the index 0, 1, and 2 because slicing ends on the element before the stop value. From the list, we are going to pick the 0 index, which is 10, the first index, which is 20, and the second index, which is 30. For the next part, we are slicing to the end. Whenever we slice to the end, we leave the stop value empty whilst we specify the start value. So on line 5, we have print into brackets numbers. In the square bracket, the start value is 2 and an empty stop value. So here, it means we are going to begin slicing from the elements having the index 2 straight to the end. On line 6, we are extracting every nth element. So here, we are introducing the step which is 2. It means we are going to pick every value at an even interval, which has been specified with 2. On line 7, we are going to reverse a sequence. So anytime we want to reverse a sequence, we use -1 as the step value. And for the last part, we want to slice the last n items. So n here is any value that we want to specify. So on line 8, we have print into brackets numbers, and then into bracket the start value is -3, and then we have an empty stop value. So it means we are going to start slicing from the last but 3 elements all the way to the end. Let's run this code and see the results. From the results, the first part we have 20, 30, 40. This is coming from line 3, where we extracted the range with the start value of 1 and the stop value 4. So it means here we pick the indexes 1, 2, and 3. Looking at the list, the index with 1 is 20, the index with 2 is 30, and the index with 3 is 40. That's why we are having 20, 30, 40. With the next part, we have 10, 20, 30. This is coming from line 4. We are slicing from the start. So it means we are going to pick the index 0, the index 1, and index 2. The 10 is having index 0, 20 is having index 1, and 30 is having index 2. That is why we are having 10, 20, 30. For the next parts, we have 30, 40, and 50, where we are slicing to the end. So here, we are going to begin at the index 2. From the list, 30 is having index 2. So we are going to have 30, 40, and 50. With the next part, we have 10, 30, and 50. This is coming from line 6, where we are extracting every nth element. And for the n, we specified it as 2. We are going to begin picking values from index 0. So with the index 0, we have 10. And then we are going to skip the next element and then move on to the other element, which is 30. We are also going to skip 40 and then pick the element 50. That's why we are having 10, 30, 50. For the next part, we have 50, 40, 30, 20, 10. This is coming from line 7, where we've reversed the sequence. For the last part, we have 30, 40, 50. This is coming from line 8, where we are slicing the last n items. So here, we are beginning from the last but 3 elements, which is 30. So we are going to pick 30, 40, and 50. Let's look at some of the list methods. First, we have index, which returns the first index at which an element or a value occurs. We also have count, which returns the number of times an element or an item appears in a list. We also have sort and reverse. The sort arranges the list items in ascending order. The reverse also flips the order of the list. We also have the append, which adds a single item to the end of a list. We have the pop method. This is used to remove an item or element from a list given its index. In case you are using the pop and you don't specify the index, it is going to remove the last item or element. Let's take a look at some of the examples. In this example, we've created the variable numbers and we've assigned it to the list containing 10, 20, 30, 20, and 40. For the first part, we are going to display the index of 30. So here we have print into brackets numbers dot index into bracket 30. So this is going to return the position or the index at which 30 is. On line 4, we want to display the total number of times 20 appears in the list. On line 5, we are using the pop method. So we have numbers.pop. So here, because we are not giving any index, it is going to remove the last element. For the second part, we've created a variable called numbers2 and we've assigned it to the list 1, 2, 3, 4. On line 11, we are going to add the element 5 to the list and then we are going to print the results. For the third part, we've created a variable and we've assigned it to 7, 4, 3, 6, 9, 1, and 5. Here, we are going to sort the list using the sort method and display the results. For the last part, we've created a variable numbers4 and assigned it to 1, 3, 5, 6, 9, and 4. We are going to use the reverse method to reverse the order of the list and then we are going to display the result. Let's run this code and see what happens. In the results, we have the first part to be 2. So this is coming from line 3, which displays the index of 30, which is 2. The second part, we have 2, which gives us the total number of times 20 appears in the list. For the next part, we had to display the results from numbers after removing the last item. So you can see we have 10, 20, 30, and 20. The 40 at the last element has been removed from the list. For the second part, we are looking at the append. So here we've added the element or item 5 to the list. So we're having 1, 2, 3, 4, 5. For the next part, with the sorts, you could see we have 1, 3, 4, 5, 6, 7, and 9, which has been the sorted for of the previous list. For the last part, we have 4, 9, 6, 5, 3, and 1, which is the reverse form of the initial list. A tuple is an ordered immutable collection of items. So here we have a new keyword here, immutable. It means that for tuple, the items or the elements cannot be changed after creation. Tuples can be created with the parentheses or using the tuple constructor, which we'll look at later. Tuples can store numbers, strings, boolean, lists, and other data types. Okay, for this example, we've created a variable called data and we've assigned it to the tuple. So here we have parentheses and we have 10, which is an integer. We have Python, which is a string. We have true, which is a boolean, and also we have 3.5, which is a float. Also know that tuple can allow duplicated entries. For tuple, it has only two inbuilt methods. These are index and count. The index returns the first index at which a value occurs. The count also returns the total number of times an item appears in a tuple. So let's look at an example for each. In this example, we've created the variable data and we've assigned it to the tuple. We have 10, we have Python, true, 3.5. We are going to display the data in the console from line 3. For the next part, we've created a new variable called numbers. We've assigned it to 10, 20, 30, 20, and 40. On line 8, we are going to check the index of 40, and on line 9, we are going to check the count for 20. Let's run this code and see the results. For the results, we have 10, Python, true, and 3.5. So this means we've assigned the tuple to the data variable. For the next part, we have 4. So this shows that 4 is the index of 40. For the last part, we have 2, which means that 20 appears twice inside the tuple. A set is an unordered collection of unique items. So here we have a new keyword, unordered. This means that sets do not preserve the order of its entries or elements. Sets are mutable, meaning we can change or modify their contents after they've been created. We can create sets by using the curly brackets or the set constructor. The most important part of sets that we have to take notes is that set does not use indexing. It uses hashing for its elements. So previously, we've looked at lists and tuple, and we said both of these data types use indexing, which means the elements or the entries were identified based on their position. But when it comes to sets, we use the term hashing. So for hashing, each element or each entry are given unique identity. This means you cannot duplicate entries with sets. For this example, we've created a variable called num_data, and we've assigned it to 1, 2, 3, 4 as a set. Each of these entries or each of these elements are given unique identity. So 1 is having its own unique identity, 2 as a number is having its own identity. Let's take a look at an example to understand better. In this example, we have the first part, which is creating a set. Created a variable called num_data, and we've assigned it to 1, 2, which are integers. We have Python, Java, sum, and use as strings. So on line 3, we are going to display the sets in the console. For the next part, we are using the set constructor to create sets from a list. So we've created a new variable called numbers, and we are using sets into brackets, and then we have the list 1, 2, 3, 4. So this is going to convert the list into a set. For the third part, we've created a new variable called values. So in here, we have 1, 2, 2, we have 546, we have 3, 4, and 10. We also have 436. We have 7. And then for the last element, we have 71,101. On 11, we are going to display the results from the value variable to show that we cannot duplicate entries in sets. Let's run this code and see the results. For the results, you can see we have 1, 2, sum, youth, Python, and Java. You could see the order of the outputs is not the same as the original set. So this shows that sets are unordered. For the next part, we have the sets containing 1, 2, 3, and 4, which means we have successfully converted a list into a set. For the last part, we have 1, 2, 3, 5, 4, 6, and the rest. So from the results, you could see that the value 2, which was initially duplicated in the first set, is showing only once in the result, which means that we cannot duplicate entries for sets. A dictionary is a data type which stores data in key value pairs. So a dictionary is an unordered, mutable, and indexed collection. Dictionaries can be created by writing key value pairs inside curly brackets. So in here, we connect each key to the value using the colon. For the example, we've created a variable called dict and we've assigned it to a basic dictionary having key value pairs. So for here, the name and the age serves as the key, whilst the IMA and 18 serves as value. The last information to take note is that for dictionaries, each key must be unique. Let's look at some of the dictionary methods. For the first one, we have get. This is used to retrieve values from the dictionary using their keys. We also have the del, the delete, which removes an item from a dictionary using its key. We also have the clear method, which is used to remove all items from the dictionary. In this example, we've created a variable called student and we've assigned it to the dictionary. We have the keys as name and age, and then we have the values as IMA and 18. We want to retrieve the value of name, so we have print into bracket student dot get, and then we are using the key name. For the next part, we are looking at delete. So we've created a new variable called student2 and we've assigned it to a new dictionary. So for the keys, we have name, age, and grade. And for the values, we have Bella, and we have 20, and then we have B. On line 10, we are going to delete the second key value pair or entry, which is age. So we have del student2, then in the square brackets, we have age as the key. So this is going to search for the key, which is age, and then delete the pair as an item. Then we are going to display the results from line 11. For the last part, we've created a new variable called student3 and we've assigned it to a new dictionary. So for the keys, we have name, age, and grade. For the values, we have Chris, 19, and A. On line 15, we are going to remove all items in the dictionary by using student3.clear and we are going to display the results. You can see we have displayed the results from the student's variable. For the second part, which is coming from line 4, we have Emma, which we retrieved by using the key name. For the next part, we have the new dictionary, which is having the keys name and grade. And then the values, we have Bella and B. So here, we've removed the A20 item. For the last part, we've removed all items from the dictionary using the clear method. In dealing with Python data types, we have two important concepts we need to take note of. We have type conversion and typecasting. Let's look at type conversion. Type conversion occurs when a data type is automatically converted into another during operations. So this is to ensure that the values are compatible and then we can get an accurate result. Python usually converts to the more general type. So when you look at this flow, we have int and float and complex. So it means that anytime you are performing an operation and then you have an integer and then a float, Python is going to automatically convert the integer into a float. That is more of the general type. Also, if you are performing an operation and then you have a complex number, a float, and an integer, Python is going to convert the float and the integer all to complex numbers to perform the operation. For typecasting, we manually convert the value from one data type to the other. So here we have several typecasting functions. Here we have integer, we have floats, we have string, we have bool, we have the list, we have tuple, we have set, and then we have dictionary. Let's look at some of the examples to understand better. In this example, we have created two variables A and B. We've assigned A to 5 and B to 2.5. We've also created another variable called results, which is having A plus B. We are going to add the variables A and B and displays the results. Type conversion is going to take place. So Python is going to convert 5 into 5.0, which is a float, and then perform the operation. For the second part, we've created a variable called num and we've assigned it to a string, which is 10. And we've created another variable called converted1. So we have converted1 is equal to int into brackets num. So here we are using the int as a typecasting to convert 10 from string into an integer. We are going to display the results from line 12. For the last part, we've created a variable called data and we've assigned it to a list. The list are having two items. So we have name and IMA as one item, and then we also have age and 18 as another item. So we are going to convert this list into a dictionary. So we have converted 2 equal to dict into brackets data. In converting to dictionary, we are going to use the first element of each part as the key and then the second element of each part as the value. Let's run this code and see the results. From the results, we have 7.5. So here Python converted 5 to 5.0 and then we added it to 2.5 and then we have 7.5. For the second part, we've converted 10 from string into an integer. For the last part, you can see a dictionary which is having the keys name and age and the values as Emma and 18. To end this lesson, let's look at two more methods which are very important. We have the type and then we have its instance. The type method is used to check the exact data type of a value. We also have the its instance which returns a boolean. So this is used to check whether a variable belongs to a specific type. So let's take a look at an example of each. In this example, we have a long list of code where we are going to check the type of some values. On line 2, we are checking the type of the number 10. On line 3, we are going to check the type of 3.5. On line 4, we are checking the type of Python. On line 5, 6, and 7, we are checking the type of the list, the tuple, and the set respectively. And then on line 8, we are going to check the type of the dictionary. For the second part, we are going to check whether a value belongs to a certain data type. So we have print into brackets is instance, and then we have 3.5 and int. So this is going to check if the value is actually an integer and it's going to return true or false. So let's run this code and see the results. From the results, you could see from line 2 we have integer, line 3 we have a float, line 4 we have a string, line 5 we have a list, on line 6 we have a tuple, on line 7 we have a set, and for line 8 we have a dictionary. For the next set, we have false. This is coming from line 13. This means that 3.5 is not an integer, but it is a float. For line 14, the Python is actually a string, so it returns true. For line 15, it returns false. This is because the square bracket 1, 2, 3 is a list and not a tuple. For the last line, line 16, it returns true because the curly brackets 1, 2, 3 is actually a set.